I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, I am going to discuss one of the most important topic, that is transformer losses. What do you mean by transformer losses? You know that the transformer is designed for very high efficiently, but some energy will be lost during the normal process. This wastage of energy is generally called transformer losses. How do you classify the transformer losses? Transformer losses are broadly classified into two. They are copper losses and core loss. Core loss is also known as iron loss. The core loss will be subdivided into hysteresis losses as well as eddy current losses. Let us discuss in greater details. First of all, I would like to talk about what do you mean by core loss or iron loss. So the core losses are majorly occur in the transformer core. You know that transformer core is a part where the flux will be transferred from primary side to secondary side. So the losses will be mainly occurring due to the varying magnetic field. The major reason for varying magnetic field is because the flux is having the sinusoidal nature. You already know that the flux phi is equal to phi m sin omega t. So the reason can be justified in two manners. The first one is known as hysteresis losses, and another type of loss is known as eddy current loss. So the major reason for hysteresis loss is because of the repeated magnetization and demagnetization of the core. You have to consider the BH curve. You can see the coercivity, coercive force, and remnant magnetism. Then you can residual magnetism. Those parameters you can consider. So if you observe BH curve very properly, then you will understand the particular area. For example, you will be getting the area like this. Okay. So in this area, you are able to get it. If you plot a BH curve, each point there will be each and every point there will be significance like residual magnetism, coercivity, etc. So, however, we can say as the area of this particular curve is high, the losses will be automatically high. The hysteresis loss will be mainly depending on the core material. It is better you have to maintain the material like a silicon steel. The silicon steel has less value of hysteresis. If because of less value of hysteresis, the hysteresis loss are significantly less. Okay, so it is better to go for the silicon steel of the core so that hysteresis loss can be reduced. Let me explain the equation of hysteresis loss in the coming slide. So before closing this, I wanted to add one more reason of core losses, that is called eddy current loss. The eddy current loss is because due to the electromagnetic induction, you know that the E is equal to N d phi by dt. So by the way, if the core is short circuited, okay, then if the load is connected to the output, so such cases, what we can do is there will be like a small amount of the circulating current which will be forming inside the core. The small amount of circulating is current is generally known as eddy current. Okay, so it is happening due to electromagnetic induction. Plus, you are considering the circuit very closed. There will be circulating current that will be flowing towards the core of the transformer. Because of that, bulk amount of heat will be dissipated. So, okay, so that is generally called as eddy current loss. Now you have to minimize the eddy current loss by providing the proper lamination in the transformer core. Okay, the reason is if I provide proper lamination, the area is actually getting reduced, getting increased. Because of that, surface area is getting increased, resistance comes down, so that losses will be reduced. That means circulating current will be minimized. So hysteresis loss can be computed by using the formula pH is equal to eta Bm to the power 1.6 into Fe. So, where pH is known as hysteresis loss in terms of watts only, eta is the Steinmer's constant, Bm is the maximum flux density. It is the ratio of total flux divided by unit area. F is the supply frequency and V is the volume of the core. So, this is a general equation of hysteresis loss. While talking about the eddy current loss is mainly due to the circulating current which is happening due to the electromagnetic induction. The circulating current, that means the eddy current leads more amount of heat loss. Eddy current can be computed using the formula Ke into B to the power square F square T square V. Here you can remember P is nothing but eddy current loss. K is the constant that depends on the eddy current. Then Bm is the maximum flux density. F is the supply frequency. T is the thickness of the lamination, and V is the volume. So try to reduce the thickness. Okay, so that the ultimate resistance will come down. Okay, so that's what we'll be going for like a laminated core in the transformer to minimize the eddy current loss. So if I talk about the second type of loss, that is called a copper loss, that is generally called a I square R loss. Okay. Here you need to use high quality of the copper material to minimize the losses. Okay. The higher current, that is equal to higher the copper loss, to so reduce it by using the lower copper wires. So that is the another major loss. Copper loss can be easily calculated by using I square R formula. So I square R can be applied at the primary as well as secondary. There are other losses like a stray loss. It is mainly due to leakage flux affected by the metal parts. If I talk about the dielectric losses, it is majorly occurring due to the insulation of winding, then usually minimal. Dielectric losses are less only, but you should be very careful. Mechanical losses includes vibration, noises, humming noise, etc. These are belong to mechanical losses. So generally we can write the total losses can be written as core loss and copper loss. The core loss is constant. It will be directly depending on the voltage, where the copper loss will be directly depending on the current. Core loss is proportional to voltage, where copper loss is proportional to current. So these are the basic information about transformer losses. I would like to ask you any question. If you have any doubts regarding this topic, kindly revert in the comment box. I'm happy to explain again. Those who are observing, if those who wanted to observe the content properly, then you have to refer the previous year videos. Thank you very much for watching this video. Happy learning. Wish you all the very best for your exam point of view.